All right, hi everybody. Welcome. I just added in Convai, which is an AI software or AI website. This is the website here. It's the character description, and then I just loaded it in, followed their tutorials, and pretty simple, pretty easy. Just make sure. Okay. All right. Now I've got my sample character over here. And I'm just going to ask him some questions about the 3-cell model. I just push a button, and then it records me or listens to me, and then give me a response. So let's ask it about the subtropical jet, how the subtropical jet's formed. Hi, how's the subtropical jet formed?
The subtropical gyres are formed by the combination of ocean currents and the Coriolis effect. The Coriolis effect causes ocean currents to deflect to the right in the northern hemisphere and to the left in the southern hemisphere. This deflection causes water to accumulate in the center of the gyre, forming a circular pattern of water movement. These gyres are also affected by the prevailing winds, which create a spiraling effect in the water.
How is the subtropical jet stream created?
The subtropical jet stream is formed by horizontal temperature contrasts and the conservation of angular momentum. Differential temperatures along the jet stream create a cold air mass on the poleward side and a warm air mass on the equatorward side. The jet stream is formed where these two air masses meet, and the velocity increases to conserve angular momentum. This creates a narrow band of strong winds that can extend thousands of miles and be hundreds of miles wide. The jet stream also has seasonal variations, with a lower altitude and faster winds in the winter and a higher altitude and slower winds in the summer.
Jet streams, so those go up and down. That'd probably be really nice. I'll add it later. But let's see, what else should I ask? Let's ask it about the. Let's ask it about the formation of the equatorial low. About the equatorial low. Can you tell me about the equatorial low?
I'm sorry, but I'm not sure what you mean by the actuarial. Can you please provide more context or clarify your question?
Can you tell me about the equatorial low?
Certainly. The equatorial low, also known as the intertropical convergence zone, is a belt of low pressure located near the Earth's equator. It is formed by the convergence of the northeast trade winds in the northern hemisphere and the southeast trade winds in the southern hemisphere. The warm air from these trade winds rises, creating a region of low pressure. This area is characterized by warm, moist air and heavy rainfall, making it a prime location for tropical rainforests. The location of the equatorial low can shift seasonally, depending on the position of the sun. During the northern hemisphere summer, the equatorial low moves northward, while during the southern hemisphere summer, it moves southward.
Why is there a high above the equatorial low?
The high pressure above the equatorial low is known as the subtropical high. This high pressure is formed by the sinking air from the equatorial low. As the warm air in the equatorial low rises and cools, it forms clouds and precipitation. The precipitation releases heat, which warms the atmosphere and causes air to rise. As this air rises, it cools and sinks back down at higher latitudes, forming the subtropical high. This high pressure is characterized by dry air and clear skies, making it a favorable location for deserts. The location of the subtropical high can also shift seasonally, depending on the position of the sun. During the northern hemisphere summer, the subtropical high moves northward, while during the southern hemisphere summer, it moves southward.
Let's try to be more specific about the high height above the equatorial low. Can you tell me about the high height center above the equatorial low?
I think what you are referring to is the subtropical high, which is a high-pressure
No.
system that... I apologize for the confusion earlier. Can you please clarify your question about the high height center out above the equatorial low?
Yeah, I guess I need to change its like knowledge base to. Maybe it's because I don't have meteorology like the next bit of information, and that's where you actually learn about that stuff. So, can you tell me about the chimney effect?
The chimney effect is a vertical motion in the atmosphere that is created by a combination of convergence at the surface with divergence above it in the upper atmosphere. This creates upward vertical motion between the surface and upper air. This type of motion is often associated with thunderstorms, where warm, moist air rises and cooler, drier air sinks. As the warm air rises, it cools and water vapor condenses, forming cumulus clouds. The convergence at the surface creates an area of low pressure, which draws in more warm, moist air. The divergence in the upper atmosphere creates an area of high pressure, which causes the rising air to spread out and flow away from the thunderstorm. This creates the chimney effect, as the rising air is confined between the high and low pressure systems. The chimney effect is also important for atmospheric circulation, as it helps to transport heat and moisture from the surface to the upper atmosphere.
All right, I can still ask it about things. I can actually ask it from anywhere, and it'll still hear it. But I'm going to ask it about let's ask it about curvature vorticity instead. I asked about shear vorticity earlier. Can you tell me about curvature vorticity?
Certainly, curvature vorticity is a type of vorticity that arises due to changes in wind direction over time. Or in other words, due to the curvature of the flow. When air moves along a curved path, it experiences a change in direction, which causes the air to deflect to the right in the northern hemisphere and to the left in the southern hemisphere. Due to the Coriolis effect, this deflection causes a rotational motion in the air, which is known as curvature vorticity. The sign of curvature vorticity depends on the direction of the wind and the direction of the curvature, with positive vorticity indicating upward vertical motion and negative vorticity indicating downward vertical motion. Curvature vorticity is an important factor in the formation of weather systems, such as cyclones and anticyclones, and plays a key role in the atmospheric circulation.
Okay. Let's ask, how does curvature vorticity and shear vorticity relate to relative vorticity? How does curvature vorticity and shear vorticity relate to relative vorticity?
Curvature vorticity and shear vorticity are two components that make up the relative vorticity. Curvature vorticity is caused by the change in wind direction over time, or the curvature of the flow. Shear vorticity is caused by the change in wind speed over distance. When these two types of vorticity are added together, they create the relative vorticity. The relative vorticity is an important parameter in atmospheric dynamics because it helps to determine the strength and direction of weather systems. Positive relative vorticity is associated with counterclockwise, cyclonic, rotation and upward vertical motion, while negative relative vorticity is associated with clockwise, anticyclonic, rotation and downward vertical motion. Understanding the relative vorticity is crucial for weather forecasting, as it can indicate the potential for the development of severe weather such as thunderstorms, tornadoes, and hurricanes.